If you haven't looked at your energy bill lately, you might want to be sitting down when you open the envelope. Have you had this experience? Stay tuned and we'll tell you how to cut that thing down. Welcome to another episode of Thoughts from the Crawl Space. Today we're going to be talking again about energy efficiency. What are some things you can do in your house that will help lower energy costs, but without costing you an arm and a leg? We'll talk about some of the myths, some of the things that people value highly but really don't make that much difference in return on investment. So let's jump right in. So energy costs have definitely risen over the last decade. I think what you're seeing with these data centers going in and the incredible amount of energy it takes, a lot of that cost is spread to residents in the area. Fair or not, it's the reality of the situation. And so anything you can do to reduce costs is big. You know, over the years, even the decades now, what's the push been about in-home energy use? Oh, replace those incandescent bulbs with LED lights. Replace them with, used to be the compact fluorescent, and then it was LED. And all that's supposed to reduce energy costs, while those lights themselves cost much more than incandescent bulbs. Has it really lowered your energy cost? You've done all these things they tell you to do, and your energy costs still keep going up. So that's probably a topic for a different day, but we're going to talk about what you can do in your home, relatively low cost, to affect the energy bill in a positive way. In other words, it's going down without living like someone that doesn't want to use their electricity all the time. So heating and cooling costs account for roughly 40 to 55% of a typical home's energy use. So obviously this time of year, we're getting into spring. Things aren't as cold as they were, but this past winter was relatively brutal in some areas. Heating costs way up. And as summer approaches, if you use air conditioning, that's going to affect it as well. So why does it cost that much? Well, part of it is you have a leaky house and you got a lot of air moving in and out of it. And so it costs more to heat it if you have drafty windows, doors, attic, etc. So the number one angle in all this is not, quote, going green. It's about cash flow and it's about your comfort. The number one ROI upgrade is insulation and air sealing. You've probably heard a lot about, well, do you have enough insulation in your attic? Well, attic insulation deficiencies are among the biggest common inspection findings. We're not going to be real bent out of shape over it. It's just what your house has. It's not necessarily a defect. It's just what your house has. And it's also an area that you can improve it. So if we go into the attic and we see deficient attic insulation, it will be noted in a home inspection report. And then it's your choice what you want to do about that. So why is insulation a big deal? Well, you've all heard the term, and hopefully you learned it in school, that heat rises. As your home heats, and we're going to talk primarily about heating in this session because we're in the northern climate and you're going to deal with heating issues more than you'll deal with cooling issues, which is what, if you were in Florida, you would probably deal with that a whole lot more. So as heat rises, your furnace produces heat, it warms the air. Well, as it warms, it rises. And as it rises, it hits that ceiling, and then it gets into the attic, and then it escapes. And so we'll talk a little bit more about that in a minute, about how to stop some of that. But that is just a very simple explanation of how heat rising and easily transferring through your attic, through your ceiling, is costing you a lot of money. Now, we've done home inspections before where someone inadvertently or intentionally has had ductwork going into the attic and actually literally heating the attic or cooling the attic, depending on the time of year. And that's a massive energy loss. You wouldn't even think of doing that, right? The attic essentially is outside air, especially if it's ventilated properly. And so no one would even think of doing that, but inadvertently, that's what you're doing if you don't have good air sealing, and that's point number 2. Your heat loss is almost all related to the air sealing between And but I mean, I'm using ceiling twice here. The ceiling is the top of the, the drywall that you see at the top of the room. Ceiling, SEALING, is the gaps that you don't see on top of that drywall ceiling, okay? And so wherever you have a wall coming together with the ceiling, you're going to have a potential for a gap right there that you can't see until you go up into the attic and you pull the insulation back and it's like, oh, we do have a little gap there. All those little openings along all the walls where they meet the ceiling, those are potential heat loss areas if they're not properly sealed. And how do you seal those? Well, there's a variety of ways, but here, some of the other areas where you're losing is duct penetrations. If you have ductwork going through the ceiling, if you have pipes going through the ceiling, you don't think about it because it's a small gap, but think about if you added all those gaps up in your house and put them in one area. Think about how big that hole might be going from the house into the attic. If you just have an 1/8 of an inch gap at all the walls and all the ductwork penetrations and all the plumbing, you potentially could have a foot or more opening by the time you're done. And it's crazy to think about, but that is not uncommon in homes built in the 50s and the 60s and the 70s. More homes now are being built a little bit tighter, but still the quality of construction has a lot to do with it. Design, the layout, where the ductwork goes, and things like that. So we're also going to dive into insulation. What kind should you use? Spray foam, blown-in cellulose, or fiberglass bats? What are some of the pros and cons from those? Well, we'll dive in right now. Spray foam or blown in. Spray foam is the kind that comes in. It's usually professionally installed. It goes on wet. It expands, and then it just seals kind of everything right in place. This is great for like a skim coat around the perimeter of your house when you're building it. It seals everything where the studs meet the OSB on the exterior wall. It firms things up. It stops drafts, and then you can add any insulation you want in between the stud bays when you're building. Well, you can do this in your attic as well. Now, you can only do this if you don't have insulation up there to begin with. So there's two ways. One, do it when you're building the house, or two, remove the current insulation, spray foam it, then add insulation again. You're not typically going to see spray foam used as the entire insulating factor in an attic. However, in some jurisdictions, some builders will still use spray foam on the underside of the roof. And then you essentially, and you don't have any ventilation up in the attic, or at least you shouldn't, you essentially turn your attic into a living space. So there's a few ways to approach it that makes it pretty darn tight. There's also science out there that says it may cause condensation and rotting on the roof decking, which would be a big no-no. But for purposes of this discussion and what we want to do with air sealing your attic, that's a great way to do it. You do it during construction, or if you already got a house and they already have insulation up there, you would have to pay to have that removed, then sealed, then re-insulate it. So not a cheap fix, but it's still your biggest energy loss potential in the house. So as far as the type of insulation to use between blown-in cellulose, there's also blown-in fiberglass or fiberglass bats. There's rock wool. There's just a variety of insulations. They're all going to have some, they are going to be similar in how they stop airflow. When you look at insulation, they have an R value on them. R value simply means the resistance value, the resistance of transfer of air from one area to the other. So if you have an R13, that's going to have less resistance value than R30. Typically in a 2x6 stud wall, you're only going to be able to get up to about maybe an R19 or even R25 with bat insulation. Now if you skim coat it with spray foam like we just talked about, and then add a different insulation, you can up that R value a little bit. Most new homes are required in their attic to have a minimum R value in the attic of between R38, even R50. Now, R50 is getting up there in number of inches of insulation. We'll see with fiberglass insulation, blown fiberglass, typically you're only going to have a 2.7 R value per inch. Cellulose, blown cellulose will typically have a little bit over 3, so a little bit more value. But the problem we're finding is the blown cellulose is heavier, and as they add 13, 14, 15 inches of that, it gets heavier and it pushes down on the drywall. So they've gone to blown fiberglass in a lot of situations where it's lighter weight. You have to add even more of it, but it's still lighter weight overall. You might have 20, 24 inches up there of insulation, which is just crazy to think about. But it's, you have an attic with 24 inches of insulation, you just can't walk through it. It's covering everything and you can't see anything. So what we see in home inspections, you might see a lot of insulation. The homeowner can advertise, hey, I just added more insulation. You're going to want my house, right? Well, we don't know how well it's sealed. We really don't, and you're not going to know either until you move in. So what if somebody's walked on it? We don't want to walk on new insulation because it compresses it and reduces the R value. One thing that helps the R value and creates the good effect with insulation is the air. And that's why blown insulation is so popular. But when you go compressing that, you hire somebody to come do some work, they're walking all over it, guess what happens? They compress it, they've reduced the R value. If it gets wet, many times you can't undo that. It's like the toothpaste out of the tube. You're not going to put it back in, right? So here's a topic for debate. What about new windows? How can new windows help you with your home? Why do homeowners spend $15,000 on windows before they spend $1,500 air sealing their home? Now, taking insulation out and putting insulation back in is going to cost you way more than $1,500, but the actual task of air sealing is roughly going to be $1,500. Windows are a big one. Why do people put in windows? Well, we'll talk about that a little bit later. But another thing that you can do as far as energy efficiency is HVAC maintenance. Do you upgrade it or do you maintain it? HVAC lifespans, heating and cooling, your furnace, your air conditioner, about 15 to 20 years on average. Higher efficiency systems can reduce cooling costs by 20 to 40% compared to older units. And it's based on we won't get into the details here of the SEER rating, but a higher SEER rating can reduce cooling costs. For example, a 16 plus SEER rating, basically is energy efficiency, can reduce your cost by 20 to 40% compared to a 10 SEER unit. Oversized systems reduce efficiency and comfort. This is a big misunderstanding. A lot of times we will get potential buyers that say, that air conditioner outside looks so small. Is it big enough for this home? Well, many times it is. And if anything, you want your air conditioner to be slightly undersized. If it's undersized, it's going to run more often. You're like, what the world are you talking about, dude? Well, if it runs more often, or if it runs longer, once it kicks on, a couple of things happen. One, you are dehumidifying the air better instead of just a hard blast of cold air to cool everything down, and then it stops. And it's not stopping and starting as much. Stopping and starting is what kills the life of an air conditioner. If it's oversized, it's certainly going to cool your house. It may not dehumidify it as well, and it's going to wear out quicker because it's starting and stopping so often. So an air conditioner, number one, it needs to be sized properly. But if it isn't sized properly and it's slightly undersized, as long as it can keep up in extreme temperatures, that's a better way to go than having one that is oversized. Now, if you have one right now that's oversized, you're probably not going to gain much by paying several $1,000s to put in a properly sized one. It's going to take a long time to make that up, but just something to look at. Dirty filters. When's the last time you checked the furnace filter? Most people never even think about it until maybe they're beside it or it quits working and they wonder why and they call a tech out And have you changed your filter recently? Furnace filters can get so dirty that they just don't allow enough airflow and your furnace shuts down. And so that's the best case scenario. The worst case, they can start falling apart and get sucked into the blower motor and cost thousands of dollars to repair. So make sure you get your furnace filter checked, and also coils. The coils are something you can't see. The typical homeowner is not going to be able to get into that. So get it professionally serviced at least once a year is my recommendation, and that can help reduce. Is it a big energy saver? They estimate 5 to 15%. If your bill's $300, 5% is $15 that you would save per month. So an extra couple coffee. Excuse me. That's an extra couple of cups of coffee. That's a tongue twister that I didn't even plan on. But another one, ductwork. So we've talked about why energy efficiency matters, and having trouble talking today. The number one upgrade, which is insulation and air sealing. We've talked about should you upgrade or maintain your HVAC unit. Number 4, ductwork. This is a hidden energy drain. Ductwork goes everywhere. It's in sections, so every potential section has a gap if it's not installed properly. The EPA estimates that the average home loses 20 to 30% of conditioned air due to duct leaks. Can you believe that? 20 to 30% of your air. That's 20 to 30% of your bill is in ductwork leakage. Leaky ducts in attics and crawl spaces, nobody looks there. They might put it in, even potentially they did a great job during construction, but I can't tell you how many attics we go into where the ductwork is disconnected. The insulated duct, if they have insulated ducts, is torn out. Mice have gotten into it, other rodents, and just needs work. And you're losing a ton of air and energy efficiency in the attic or crawl space. Not to mention, if you get holes in it, it draws air into it and can contaminate the air quality in your house. So duct sealing is a big one. They use a mastic material. You can get spray foam insulation on it even. It does cost a little bit, but I would highly recommend that in insulation for ductwork in the attic and the crawl space. Number 5, what about smart thermostats and controls? That's the trend in recent years, right? Those old thermostats, they're no good. Just like incandescent bulbs. Get rid of them, right? Do the smart thermostat. Devices like the Nest claim on average a savings of 8 to 12% on heating and cooling. So think of these last two topics, ductwork and smart thermostats. 20 to 30% plus 8 to 12%. Well, you're starting to really add up here. 30 to 40% of your savings on heating and cooling if you change some of these things. Upgrade your filter. Change your filter. Ductwork. Insulate the ductwork. Smart controls like Nest. Why are they so efficient? Well, you can program them. When you're not there, it's not going to heat as well or cool as much as you would when you'd want it to be there. So that's a big part of it. It's great for disciplined homeowners. It's less helpful if your insulation and your ducts are poor. So these things all kind of work in concert with one another. Technology cannot fix air leakage. So a programmable thermostat has an advantage if you've already taken care of your ductwork, you change your furnace filter, you get it serviced regularly. All those things work together and just make for one happy family. Windows, we talked about this a little bit ago. Point number 6, windows, are they possibly the most overhyped upgrade? Well, possibly. There's certain aspects of homes where, you have windows that leak extensively, and certainly windows are look at it this way. Windows are a hole in the wall. The R value on glass is very minimal. We talked earlier about R value in walls that could be 25, even 30. A window is probably going to be between 2 and 5 of an R value. So the more windows you have, the more energy cost it's going to take. And if you spend $15,000 on windows or 20 or 30 on windows, making that up it's going to take literally 15 years. And so you're improving your comfort of living there. But as far as cost to you, cash, remember we started out this episode talking about we don't care about going green, we care about cash, right? And that's what we're dealing with windows. Now, adding storm windows to currently, if you don't have storm windows, that can help. That creates an air pocket between the two. And so it's really more of a comfort upgrade than a financial one in many cases. They look beautiful, they're ease of use. Sound quality, you don't hear that outside noise as much with newer windows. But as far as the ROI on your wallet, it's just not there. Number 7, water heating efficiency. Water heating is about 18 to 20% of home energy use. Think about that water heater that is always heating water even if you're not there, even if you're not using it. What about tankless versus traditional? Well, tankless is going to cost more to put in, but it's going to cost less to operate. The average difference between a tank and a tankless isn't as great as you think it might be. I've done a little research on this. Our water heater needed replaced a few years ago. The cost to put in a normal water heater, 50-gallon, was going to be roughly $2,500. I believe a tankless was $4,500. The cost to operate a tank unit, a 50-gallon tank unit, per year was only going to be about $50 to $75 more per year than a tankless. And so if you think a water heater goes about 15 to 20 years, max, let's say 15, that's not going to add up the extra cost of putting in a tankless. So again, it's a little like windows. It sounds good. And in many cases, maybe you have a vacation home that you're hardly ever there. Yeah, it might make more sense in that case. And to have that, or just turn your water heater off when you're not there and turn it on when you show up. So what's the difference between an energy audit and a home inspection? Well, a home inspection is going to look at the safety, structural, and functional conditions of the house and the systems in the house. An energy audit uses a blower door testing unit, infrared imaging, energy modeling, and a variety of calculations to figure out what's going on with your home. All right? An energy audit is something that you can get done. Many times the local utility company will do that for you. I don't know that they'll do it for free, but they will do it for you if you call them. But I think it has some value, because how do you know where to air seal your attic if you don't know where you're getting heat loss? So the blower door trick, not really a trick, it's a technique. It puts the house under pressure, under negative pressure or positive pressure, and you can see where the leaks are occurring. And then they do that by a thermal imaging camera. It'll show, if it's this time of year, it's going to show cold in areas where you're getting a lot of leakage. If you take a thermal imager and you check really the joint of any roof, any ceiling and wall, you're going to notice, oh, that's dark blue. We're getting air leakage through there. And so that's what the blower door test does. So let's wrap this up. What can you do? What can you do to your house to quickly and relatively low cost, in a low cost way, to improve the energy efficiency of your house without replacing all the insulation, without replacing windows, without replacing your furnace? What are some really quick things you can do? Number 1, go replace your HVAC filter. I've had this embarrassment myself as a home inspector. I had forgot about it. The furnace quit working. They came out and it was simply a dirty filter. So go take care of that. Be nice to your furnace. Don't make it work so hard to suck air through a clogged filter. Seal the attic hatch. You probably all have an attic hatch of some sort. If it's in the garage, really not a concern. But if it's in the house, in the hallway, you got that little square or rectangle up in the ceiling. That is a big energy loss area. Seal that. Put some foam, some weather stripping on the bottom side of that as it sets down on the trim that's holding it in place. And that can greatly help some air leakage right there. Add door sweeps. If you have older doors or the sweeps are wore out along the bottom, you're getting some serious airflow through there, and you need to clog that up. Insulate exposed ductwork. Now, this might get into a little more money than the other 3, but insulate exposed ductwork. Seal rim joists. Rim joists are most common. You're going to see this in a basement where it's unfinished and you don't have insulation. Even if you do have insulation up in those joist bays, but you don't have it sealed, you're going to see maybe your pink insulation that's up there is going to have like charcoal looking on it, and that's due to air infiltration. So we recommend pulling that out, having it professionally spray foamed all around the perimeter of the basement or crawl space, and then putting the insulation back in. That's going to be a big energy savings. And then install a programmable thermostat. Again, we talked about this. Works in concert best if your HVAC is maintained and your ductwork is sealed. But that's one way to help just a little bit at least. And then check your attic insulation depth. R38 is the recommended minimum. In many climates, it's even recommended to be more. So those are some things you can do to help the energy efficiency. Little by little, it gives you some savings. And as everything else escalates in price, it'd be pretty cool to see your energy bill go down. So replay this episode if you need to get all those tips. Share them with your friends. Thanks for watching and listening. We'll talk to you next time.